Okay, let's go on to look at something called growth versus decay. And so in the previous lessons or videos for this section, we were looking at exponential functions that were increasing. They had a percent increase or growth rate. Now we're going to compare that to something called decay. But what we mean by growth, you can see when you have certain growth, you can see what type of equation you have here. Exponential function, the form of it. When we had 5% growth, it would look like this. And you can see the way the equations are written, it's 1 plus the rate, the percent growth rate. And so you end up with equations like that. As the quantity grows, the base ends up being more than 1 in this situation. Now, if you have quantity decreasing, we have a decay. The values are decreasing by some percent. You do 1 minus the rate of decay or percentage decay. So you can take a look at the values here. Whatever your starting value is times some base value raised to the power of x, and that base value is going to be determined by 1 minus r, where r is your percent decrease. What this allows us to do then is to put these percent increases and decrease in exponential equation form, which I had mentioned earlier. Certain rules, whether the function is growing or decaying, which means to decrease. You would look at the base value, all right? So this growth and that decay was again going to represent growing, or again, this would be a decrease. So keep that in mind there. And so just to kind of compare the two, you'll see here is y equals 2 to the power of x, y equals 1/2 x. Here are the graphs of them after we plug some values in. You'll see it's growing versus this one is decaying. If you want to do that in Desmos, you can also create a table, get the equations. You can see they have the very similar shape, but one is increasing and one is decreasing, which would be the decay or the growth rate. So I want to make sure you're familiar with kind of those terms as we talk about exponential functions.